Hello, my name is Andrew Sisler. This is a biochemistry video assignment for 350. My protein is called the S100B protein, also known as a calcium binding protein for brain injury. Let's get into this. So let's dive into the protein we're discussing, S100B. You might be wondering what exactly is S100B and why is it significant in the realm of science. So let's break it down. So what is it? The S100B is a calcium binding protein that is predominantly found in astrocytes, which are a type of glial cells in the brain. It's important to note that this protein is not just floating around aimlessly, it's intricately involved in various biological functions. What's fascinating is that the S100B is associated with several pathological conditions, meaning it can indicate problems when present in certain levels in the body. Its presence or absence can tell us a lot about the state of the brain. What is its role in biochemistry? The S100B is vital in various cellular processes, especially in neuronal growth and repair. Think of it as a supportive coach for neurons, aiding their developmental and recovery after injury. It also regulates cell activities like proliferation and differentiation, which are crucial for healing in the context of brain injury. So what is its clinical significance? The S100B is recognized as a biomarker for brain injury, particularly in diagnosing traumatic brain injury, also known as TBI. Measuring S100B levels in the blood can provide valuable insights when elevated levels indicating potential brain damage. This makes S100B essential for diagnosis and monitoring the progression of neurological disorders. So overall, the S100B is more than just a calcium binding protein. It's crucial for brain health and plays a significant role in cellular processes and in clinical diagnostics. Understanding its function enhances our appreciation of its impact on neurological health. As we discussed in the previous slide, S100B is a key biomarker for brain injuries, especially in the traumatic brain injury or TBI. But what exactly is TBI? How does it fit into the study we're talking about? TBI refers to any injury to the brain caused by an external force, like a hard knock to the head or a violent shaking. Often patients with mild TBIs don't have serious intracranial lesions, making diagnosis tricky and sometimes leading to unnecessary hospital visits. This can create a bottleneck in emergency rooms. So what's the focus of the pre-TBI study? This research looks into the diagnostic accuracy of pre-hospital levels of S100B and another biomarker, glial fibrillary acidic protein, also known as GFAP, in patients with mild TBI. Given how crucial timely diagnosis is for managing TBIs, this study tackles some important challenges. The goal here is to see if these biomarkers can help determine which patients can be safely treated outside of the hospital setting. The researchers believe that S100B levels are below 0.10 micrograms per liter, it could rule out serious intracranial issues with over 97% sensitivity. They think also GFAP might also lower false positive ratings than S100B, making S100B more crucial. Now let's dive into how the researchers concluded the pre-TBI study. They basically focused on 566 adult patients who had mild traumatic brain injuries. To qualify as mild, these patients had Glasgow Coma Scale scores ranging from 14 to 15, which is pretty standard for minor head injuries. The researchers took blood samples from these patients both before they got in the hospital and after they arrived. This way they can measure levels of the biomarker S100 and GFAP. To figure out if these biomarkers were effective, the researchers looked at a patient's medical records to see if they had any traumatic intracranial lesions. The big question they wanted to answer was, can S100B help rule out these lesions when measured before hospital admission? This approach not only simplifies how we think about these biomarkers, but also highlights their potential usefulness in real-life clinical situations. Now let's go over the results from the pre-TBI study and what they mean for our understanding of mild TBI. Out of 566 adult patients with mild TBI, 32 patients were found to have traumatic intracranial lesions. This is significant because it highlights that not every patient with mild TBI has a serious injury, which can be tricky to diagnose, especially in the ER, because usually in the ER, the faster the diagnosis, the better. This can be really concerning in trauma care. The study found that when S100B levels were above 0.10 micrograms per liter, it correctly identified every patient with an intracranial lesion. This means S100B had a sensitivity of 100% for both pre-hospital and in-hospital samples. So if S100B levels are low, doctors can feel more confident that there's no serious injury. However, the specificity, oh my god, which tells us how many people without lesions tested negative, was lower. It was about 15.4% in pre-hospital samples and 31.5% in hospital samples. This means that while S100B is great at identifying issues, it may not be as reliable as ruling out injuries for all patients. Overall, I'd say that these results make they highlight the potential of the S100B as a valuable tool in emergency care, which helps doctors make quicker and more accurate decisions for patients with mild TBI. So basically, what was this all for? What does this tell us? The study dives into how the protein S100B is used in diagnosing mild traumatic brain injury and how it can be tailored for clinical settings. The key findings revealed that S100B levels above 0.10 micrograms per liter demonstrated a striking 100% sensitivity in identifying traumatic intracranial lesions. While the specificity was lower in pre-hospital samples at 14.4% compared to 31.5% in in-hospital samples, this emphasizes S100B's potential role in emergency care. These results enhance our understanding of diagnosing mild TBI, and they indicate that S100B can effectively guide clinics in determining which patient need further evaluation and which safely avoid unnecessary emergency visits. Looking ahead, future research should focus on redefining S100B applications across diverse patient populations. Implementing the S100B testing could lead to faster decision making and more efficient emergency care. As we conclude, let's take a moment to understand the S100B protein. S100B is primarily found in the brain and plays a crucial role in various cellular functions, including supporting neurological growth and regulating calcium levels with cells. I picked this protein because we didn't really dive into calcium binding proteins in class too much, even though they came up a lot. So I really wanted to implement this because I thought it fit perfectly with my interest in trauma care and what we've been talking about with calcium binding proteins. In summary, understanding S100B is vital not only for diagnosing traumatic brain injury, but also for improving patient outcomes. And yeah, here are my references, and I hope you enjoyed.